I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider parametric equations. We are going to review the concepts. We'll take examples based on trigonometric parametric equations, convert to Cartesian equations, find domain and range, sketch graph of parametric equations, and take up examples of conic sections. Note, you should find the domain and range before finding the Cartesian equation. That will be a lesson to take home. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Amy. Hi, Amy. How are you doing?
Hi, sir. Yeah, I'm all right. Thank you. How are you?
Very good. Very good. So today, what do you want to do?
I was just hoping we could clear a couple of doubts with the parametric equations, just in terms of finding domain and range. Just carrying on from last lesson. So
Sure.
yeah.
So you can share the questions you have, and then let's see.
Perfect. So yeah, I did attempt these questions. It's just trying to just check them, just in case I've made any mistakes. That's all.
Okay. Which
So
question do you want me to work on?
5, please.
Okay. Can you please read the question?
Yeah. So eliminate the parameter t from the following parametric equations. To find the equation in the Cartesian form, state also the range of values that can be taken by x and y, assuming that t belongs to real numbers.
Correct. So what is going to be your approach?
So first, you always say the domain and range, and this is found by using the parametric equations given. So to find the domain, you find the range of x, and to find the range, you find the range of y.
So note. So that's kind of a good review. So to find the domain, this is equivalent to range of x. Is it okay?
Yeah.
And the range is equivalent to range of y. This we are talking about the Cartesian equation which we are going to form, right? This is regarding the Cartesian equation. Is it okay?
Yeah.
And we had discovered in our last class that always the questions which are asked in your case will say first part A is find the Cartesian form of the equation, right?
Yeah.
And part B is to find the domain and range of that Cartesian form. Makes sense.
Yeah.
However, we know clearly that domain and range is independent of the Cartesian equation derived.
Yeah.
Now, the important thing to note is that you might do a mistake in coming to your Cartesian equation and then both the parts will go wrong.
Right. So you lose all the marks. Yeah.
So caution. Part B first, domain range first.
Yeah. So at least you can still gain some marks.
Without even doing anything, straight away from the equation, get your domain range, get those 3 marks first. Then part A 3 marks will work on. Otherwise, you may lose all 6.
Right.
So let's be very clear about this strategy. Adopt this strategy. So we have done the first part, part B, which is what is the domain? This is a straight line, correct? So, so the domain for the function is going to be x belongs to real numbers. And as far as the range is concerned, so the range which is for the y is the the y value of t squared plus 2. It's a parabola which opens upwards with a minimum value of 2, and therefore here we have y belongs to real numbers where y is greater than equal to 2. Is that clear to you?
Cool. Yeah.
So 3 marks. We got this 3 marks of part B. Now
Yeah.
let's look into part A, which is deriving the Cartesian equations. So since you are given x equals to 2t minus 1, isolate t. So we get x plus 1 equals to 2t and x plus 1 half is t. Substitute this in the second equation, which is y equals to t squared plus 2. So t is x plus 1 over 2 whole square plus 2. And so you get your equation. You may simplify this, right?
Mm-hmm.
And then
I kind of just expanded the top, like I just did x plus 1 whole squared
yeah,
over
yeah.
4 plus 2. I didn't
Over
really
4,
fully expand.
and then 4 times 2 is 8. If you want, you can write it on the top. Add these two, right? X squared plus 2x. Depending on how much time you have, that is your
Yeah.
equation, correct? So
Okay.
you have your equation y equals to x squared plus 2x plus 9 over 4. So that's it. So now let's take up the second part. Is that clear?
Yeah. Yeah.
Good. Second part. X is given to us as 2 sine t and y is given to us as 3 cos t, correct? So first thing, let's find the domain and range. Tell me,
Yeah.
what is the domain? So domain in this case will be range of x, correct?
Yeah.
What is the range of x?
So when I did this, so I know without the 2, sine t is between minus 1 and 1, the range. So with the 2, you just times it by 2, right? So minus 2 and 2.
Correct.
Oh, okay. Just double checking, both included. Yeah.
Yes.
And then cos, yeah, minus 3 and 3. Oh, it just looked weird for some reason, and I thought it's not supposed to be. Okay.
To get
So,
some marks out of that, right?
yeah.
Then
Solid 3.
it feels good. It feels good, right? So
It does. We love obtaining some easy marks.
correct. So now let's work on the Cartesian form of this equation, right? So x
Use an identity.
y equals to 3 cos t. So you know cos square and sine square theta, when you add them, you get 1, right? So isolate sine and cos. So we have sine t in this case as half of x,
X
and
over 2.
cos t is 1/3 of y, correct?
Yeah.
And you know this identity cos square t, I should write, plus sine square t is equal to 1. So just put these values there, x by 2 whole square plus y by 3, okay, y by 3, yeah, y by 3 plus y by 3 whole square is equal to 1. What is this? This is an ellipse, right? So we get x squared over 4 plus y squared over 9 equals to 1. So ellipse, not this way, but the other way. So what you get here is an ellipse which has a major axis along the vertical side. Is that okay?
Yeah.
So when you plug in x as 0, you get plus and minus 2. Y as 0 will give you, you can get your ellipse. That's it. So you get this function also, which is an ellipse. Perfect. So we're done. Question number 5, no time and full marks.
So we don't need to like simplify like and cross multiply. We can just leave it like that in fractions.
No, that is a standard form of ellipse. Okay.
Oh, okay.
So standard form of ellipse is, let me just write down. This is very useful actually. So see, x squared over a squared plus y squared over b squared equals to 1 is an ellipse. Is that okay? Yeah.
Yeah.
Where
An ellipse again, so is that oval shape thing?
yeah, like this, egg shape.
Oh, okay. Yeah.
Now, depending on which is bigger, that is the major axis. So if A is bigger, then this is the major axis, if A is greater than B. In our case, B was 9, so then you have this form, right? You get the idea. So it all depends on which denominator is bigger, and that becomes the major axis for your ellipse. Is it okay?
So if A is greater than B, it's this way, and if B is greater than A, it's this way.
Yes, and if both are same, you get a circle. So both are same. That's what circle is, right? So,
Oh yeah.
the equations are like x square over a square plus y square over a square equals to 1. That is a circle. Do you see that? Now,
Yeah.
as soon as I change this equation and I make them different, so y square no more same as intercept, basically, it becomes an ellipse, right?
Yeah.
Now, we are trying to find the x and y intercepts, right? So how will you find x intercept? To find
Y
x
equals
intercept,
0.
y equals to 0. That means x square over a square equals to 1, or x square equals to a square. You get the idea, right? So x is
Oh,
equal to plus minus a. So that plus minus a is
it's the
your,
trans.
yeah,
Yeah.
x
And that's
intercept.
how we find the center.
Yeah.
Oh,
And
that's
b plus
cool.
minus is this, and therefore you get that minor axis if a is greater than b. Is that okay?
Yeah, yeah.
Clear.
That was interesting.
So
Thanks. It's
this is
nice when everything fits together.
yeah,
Yeah.
yeah, it is a parametric equation for an ellipse, right? And
Yeah.
if I somehow make negative in between, it becomes a hyperbola. So let's extend this to understand. So if you have x squared over a squared minus in between, you understand?
Mm.
Then becomes a hyperbola.
How does that look, so?
Okay, so how does that look? So that will look like this. Two parabolas kind of like this. Do you see that?
Oh,
So
it's
you
like
have these tangents.
reflected in the X.
Yeah, yeah, yeah. So that becomes a hyperbola. And all this combined together is called conic section.
Conic.
Yes, you soon
Oh,
learn. How do we get all these cones? Oh, let me just tell you that also in a minute. So if you have a cone, let me make two cones, right? Upside down. So we have two cones. You see that?
yeah.
So it's just a cross section of the cone which I made. Well, if you want to make it more beautiful, 3D effect, not a problem. It becomes 3D, right?
Yeah.
3D. Okay,
Nice.
fine. So if I cut it like this, what you really get is, so this surface is cut. So what you get is this shape. You see that? If you slice it like this, you get a parabola. You understand?
Oh, yeah.
You see that parabola? Correct.
Mm.
Now, if I slice it like this, right? So in this case, you get a circle. But
Oh.
if I slice it in a different way, like like this, you get an ellipse because now the axes are different. You see that?
Oh, wow. That's so
And
cool.
how,
That actually is. Oh my god.
how about cutting it
That's
like
so.
this?
Why would you get hyperbola?
Hyperbola.
What? That is really cool. So you got like all four in one. It depends how
Yes,
you cut the cone.
correct. You get the idea now?
Yeah.
So hyperbola, right? So this is two. Do you see this curve now? Do you see this curve, hyperbola?
Yeah. Wow.
So that is what the conic section is. And you have parametric equations for conic sections. Is that okay?
Yeah. Conic section. Oh, like so that makes so much sense. It's in the name about what you're doing. You're like kind of like sectioning the cone into different to find the different parametric equations.
Perfect. Perfect.
Mm.
Beautiful. So I
Yeah,
really love conic section. You should watch some of my videos on this conic section. You love it.
I will do. Yeah. That's so interesting.
Let's move on. Read the next question, please. Can you please read the next question?
Yeah, so 6. Write the parametric equations x equals sine t and y equals 2 cos 2t, where t is in between 0 and 2 pi, both included, in the Cartesian form. Hence, sketch the curve indicating the coordinates of any axes, intercepts, and of the endpoints of the curve.
Perfect. Perfect. So now you
Domain
have
and
a
range.
particular equation. You're given a restricted domain where t, that means you're looking only at between 0 to 2 pi. Correct?
Yeah.
Now, if you look into this equation, x is equal to sine t and y is 2 cos t. You get the idea?
Mm.
X is sine t, y is 2 cos t. Do they want domain range? No, they want you to sketch the curve. Okay, that's fine.
But so
Yeah, ask.
I know they didn't say find domain range, but you know how you said do it anyway. In
Yes,
this case, when I tried to put the 0 and 2 pi in the equation, I'm getting 0 on both. So I didn't know what the domain is. You know when you sub it in.
Yeah. See, the domain is the range of x. So we are looking at the range of sine t, which is plus minus 1.
So you don't look at the restricted domain they give you.
It doesn't matter because it is one full cycle. And in cos 2, t, see, sine t, let me just now sketch it. Is it okay? Not a problem.
Yeah.
Not a problem. It's good to have a clear vision of what you're trying to do. So that is your sine curve from -1 to +1. This is sine t, where this is t, and we have drawn it from 0 to 2 pi. Is that clear to you?
Yeah.
That is your domain. Domain means t value, correct?
Oh,
X.
yeah.
Parametric equation number 1, which is x equals to sine t. Now number 2 is cosine twice. So now for cosine, we have this doubled, right? Do you see this? Like, I'm not making to the scale. And the period is half. That means we'll have two waves here starting from the top, right? So one wave will finish here, the other one will finish there. So we'll start here, and then, the wave is kind of like this. You get the idea. I mean, I have to finish there. Let me just go back. Okay, correct. So when I have to finish there, let me draw this into 4 parts now because it's too small. Okay, let me make it bigger.
Wait, should I
Don't worry.
make it smaller?
I'll just see this. I'll erase. Okay, if you make it smaller, it'll be better for me. Yes. So let me make it right in the center, right?
Is that good?
Okay, that's fine.
Yeah.
Right. So we are saying that we have one sine wave here, which is this, and this is x equals to sine t. Yeah, sine t. So that means this is t for us, right? Okay. And this position here is +1. This is -1, and we have 0 and 2t, 2 pi, correct?
Yeah.
Now we have to find this graph y equals to, it was 2 times cos 2t, right?
Yeah.
2 means amplitude is doubled, and 2t means time period is half.
Half. Yeah.
So now instead of 1, you will have 2 cosine waves here, right? So let me just split this. So we have 2
with amplitude.
Yeah. So my wave will end here, right? Cosine wave.
Yeah.
You get the idea?
At pi.
Yeah.
0 and pi.
Do you see this one cosine wave, right? The second cosine wave. Do you see that? So this green graph is cosine wave. The red graph is the sine wave, x. So those are my two graphs. And my domain of this function is what? Domain is range of x, right?
Domain is range of x. Yeah.
Which is from -1 to +1.
Oh.
And range.
For some reason. Yeah, I thought because the t was
range
given.
of y. Range is range of y.
Yeah, which is between 2 and -2.
You're right. So write -2 first.
Sorry.
From here to there.
Back to number scale. Yeah.
Is that clear to you, right?
Yeah, so it doesn't matter what they give as t and whether it's restricted or not. You don't start subbing those values in.
Yeah, we have one full wave, right?
Yeah, yeah.
It is going to maximum, minimum. Yeah, if they would have restricted to quarter of a cycle or even lesser, then it was a different story altogether, correct? Perfect. Because then it was only, let's say, this much of wave, right? Then you have to go with the maximum, correct?
Oh, yeah, yeah. Okay.
But with 2 pi period,
oh yeah,
no problems
yeah,
at all.
that's clear.
Okay. Now let's look into the question. We want Cartesian equation. Okay, I can write down. This is okay. This scale is okay.
Oh, okay.
No worry. So we have x equals to sine t, y equals to 2 cos
2
2.
cos 2t.
Now you have to write the parametric equation. How will you do it? Tell me.
So I did x squared equals to sine squared t.
Okay.
And then because we have cos 2t, we can write that as 1 minus 2 sine squared t. And then sub in,
Good.
well, x squared. And then you
Perfect.
get into the equation. Simplify.
Perfect. 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 So you know y is equals to 2 times, and cos 2t, as you are saying, is 1 minus 2 sine square t, correct?
Yep.
And so it is 2 times 1 minus 2, and sine square t is given to you as x squared, correct? That's what
Yep.
you're saying, sine square t. So we have this y as equal to, you can open the bracket if you want to, 2 times minus 4x squared, correct?
Yep.
So you have your parabola. So we say y equals to 2. I mean, it's better to write the standard form, right? Y equals to
Squared
minus
first.
4x squared plus 2, correct? The only thing which you have to look into is the value of x, you remember, is from plus and minus 1.
Minus 1.
Plus and minus, right? So
Right.
now when you have to graph this particular function, the x value is between plus and minus 1. This is what you know, correct?
Yeah.
So now plug it in, that value. I mean, the graph, you know, is from going downwards. If x is 0, it is at 2, correct? So let me
Yeah.
sketch a rough graph. And if I plug in minus 1 here, then what do I get? Or plus 1 here, what do I get? Find the value of y. So make table. It's good to make a table.
Oh.
You get the idea? So put x
Idea.
value and y values, correct? So x
Did mine
value
weirdly
is
then.
minus 1 to plus 1, right? In between, you can have half and all other values also.
Mm. So what I did, could I just
Yeah, tell me.
explain quickly? That so we got the equation, and then I like took 2 out and then kind of solved for x, and then I got x equals to root 2 over 2 and also minus root 2 over 2, and then I just plot like those were the intercepts on the x-axis because it equals to 0. But
Correct.
should I do that method in terms of plugging minus 1 and 1, because I didn't do that?
No, that is okay. What you did is perfect. So basically you got the zeros, the x-intercepts of your Cartesian equation, right? Which is clear from this equation, right?
Oh yeah, yeah.
And we also have an idea that the equation is range is minus 2 to plus 2. So
Right.
in between it is definitely crossing, and you know those points. You get the idea?
Oh
So,
yeah, yeah.
so from all the information I know, I have this graph. Is that okay? Terminated at this point.
Oh, so I have
So,
to draw holes
yes,
at the
because
end.
you got in between points. Agreed. So with
Minus 2.
minus 1, when you plug it in, minus 1, in that case, what do you get? So minus 4 and 2 is minus 2 as we expected. Is that okay?
Oh, that's cool. Yeah, it's a nice check. Because I was going to say, isn't it minus 2? Because if it didn't come as minus 2, then we have an issue. Cool.
So since we know the range, you see, we know the
That's
range,
so
correct?
cool. Yeah. I love
Our,
when maths works.
our range is from minus 2 to plus 2. So definitely it has to go to 2 maximum and 2 minimum, right?
Right.
And the domain is from minus 1 to 1. So does it make sense?
It was so clear, yeah. Is it good to just mark the minus 1 and 1 points? Just to show that it's in between that domain only.
Correct. And what you
Okay.
figured out early on is this point, square root 2 over 2 x
And
intercept.
my root 2 over 2, right.
Correct.
Okay.
So when you took this on this side, so you will only say, you say 1 minus 2x squared equals to 0. So you say 2x squared equals to 1. X squared equals to half. So x is equal to plus minus 1 over square root 2, which you are rightly saying square root 2 over 2. Is it okay?
Just rationalized. Yeah.
Done?
Perfect. Okay.
So that is full marks. Is that
Yeah.
clear?
So that's where I went wrong because I got kind of thrown by the restriction they gave me with t and started shoving it all into x, and I was like, no, just think logically. How well, go back to the basics. Just find the range of x. It doesn't matter what they kind of give you. That's for later on maybe, but yeah, stick to what it is normally.
So, Amy, one more important thing which I have learned just by telling you this method is if you are running short of time, because what happens in test papers is you are always short of time. Correct?
Yeah. Yeah.
Then, since you already have worked out domain and range, you kind of know your graph that it has to go from minus 2 to plus 2, and the domain has to be from minus 1 to 1. So, at least that framework is there for you. You get the idea?
Yeah, yeah. So it makes me a lot easier to just sketch it and then quickly find.
And it actually gives you confidence that it has to go through the x-axis, and therefore we are looking for x-intercepts also. Easy calculation gives you accurate points, and that gives you a perfect graph. You found
Right,
both
right.
limits and the x-intercepts. What else you need?
Yeah. And it's perfectly in a rectangle, so that's nice. Yeah,
Because I'm
perfect.
just wondering here, calculating this is redundant.
Time consuming.
I'll say not required.
Oh, okay. Yeah, because I'm always running out of time with maths. It's
So
one of those
even
subjects.
if
It's
you
quite hard.
have time, don't think about luxury of time. No, no, no. It's a test
Yeah,
paper. You just can't sit on one thing and waste your time on it.
right.
Not required. We say redundant information. Not required.
Okay.
Those points are enough. Correct. Good job. So, any other questions on parametric?
No, that was it. It was just
Okay.
finding, the
So
domains and
we'll
range.
end this session. And can you summarize what did you learn?
Yeah, so always, whenever you get these parametric equations, immediately start by finding domain and range, which can be found from those, parametric equations, x equaling something and y equaling. So to find the domain, you find the range of x, and to find the range, you find the range of y. I know we've been repeating it throughout this whole video, but it's just so crucial because especially in the exam, you're just going to be all flustered. You would find the Cartesian form and then try and find domain and range from that. And that's just a whole nother, because when the Cartesian form kind of comes into play, it can get really complicated, it's square roots and everything. So I would not try and find the domain and range from that. And like we saw with the sketching, it's really important, like if they give a restricted domain in terms of t, since you isolated all of that, you shouldn't be like, the couple of mistakes I made was subbing that into x, and my domain and range all got like messed up. So do that separately. That's the first thing you do, and then t and everything will come later. And then in terms of sketching it, we said put the restrictions already, and then you roughly know in your head like where everything will lie and like what it should be in between. And we kind of proved ourselves as we went through it. Like when we subbed in like one of the values of -1, we got the range, and which we already calculated ages ago. So it was really nice to see that connection between the two.
Beautiful. So we'll end our lesson on parametric equations today. So we hurriedly went through questions since we have already done it last time. It was kind of a review. And I know we went fast with a purpose because, we have to just get the things going, right? Like,
Yeah. Like we are in an exam.
Good. So all the best for the exam, Emmy. And I think you are all set for it. If there's any difficulty, feel free to ask me. Okay.
Yes, definitely. Thank you so much,
Thank you.
sir. I
Have a
appreciate
great
your
day.
help. And you, sir. Bye.